Let's go. Guys, today we're doing a no lambda, no macro walkthrough of I'm Just Wild About Harry from last year, round 3 Road to Las Vegas. Let's see if we can do it in 30 minutes. It's a hard one, especially with that level 7 map. Let's go. Okay, no lambdas. I'm not going to import despite my itchy fingers. Here, we're just counting the number of apples. So we're going to say length of this. Let's see, quotient. It takes 4 apples. How many can we do? It's not the right answer. And I think it's because the emoticon here has a length of 2. So divide by 2 here. Okay. Alright, on this one, we're going to split this by that. And, okay, so now we can say the left of these are arrows, right? So let's take these arrows and make a lookup. If it's going left, it's negative. If it's going right, it's positive. So X lookup those to this thing here that we're making. That should get negative numbers. Multiply that by the value right of this. How many characters do we need? It depends. So we're going to take the length of this minus 1. So that gets our numbers. And now if we reduce starting from 0, I'm sorry, we want to scan because we need each of the intermediate values. Scan starting from 0, and then lambda accumulator and value. So we're going to mod, we're going to take the existing number, that's like where we landed at, or where we're starting at on the lock, add the number of turns, and then mod by 10. And that should get you those numbers, and we concatenate it. And I think this has to be a number. So there we go. See if that's right. No. All right, didn't look right. I don't know. I'm expecting 3-digit numbers, right? So why do we get a 2-digit number here? The anchors look fine. So what did we do? Mod a plus v. So here, let's start with a scan. 485. That wasn't the answer we got. Concat. 485. I must have just copied the last part wrong. There we go. That was weird. Okay. Here we're doing some really large number math without the lambdas. You have to get a little creative. The trick here is, as you're doing your multiplication, each number gets larger and larger, but we only ever care about the last 5 digits. So at each step, we're going to trim the answer to just get the last 5 digits. The way we'll do that is reduce, starting from 1, we're going to multiply from 1. We'll take a sequence of value, text after the power notation, whatever you call that. That's your sequence, okay? Lambda AV. So we're gonna take A and multiply it by, we don't care about V, that's just how many times we're doing it. So we're gonna multiply by value of text before. This value here. Okay, so see how big it is? That's not gonna work. So that's why we have to do the mod. And mod, I don't know what you say, modulate? I don't know, modulo by 10 to the 5th. And that will get us our answers. Humble Harry. Okay, so on level 4 now, we're looking at this text that we need to split up by sentence. So we're going to say text split that by period space. And that's going, let's do this by row. That's gonna, we're gonna want to add back the period then. Except for this last one where it doubles up the period, so I'm just gonna add a space at the end here. Okay, so we'll call this lines. And now we can come here and say equals X match this to lines. Man, that's a quick answer. Okay, this one's tricky. This one's tricky. So what we're gonna do is create an array called liked. So this is all the synonyms of liked: admired, appreciated, enjoyed, and favored. So we'll make that an array called liked. Why not? And then we're going to split text this one at the word and. Let's do that for rows because I want to filter. So we get 2 rows. The suspect likes the following, they dislikes the following. And I only want to filter on the one that has the liked in it. So what I'm going to do then is say, I'm going to search through each of these and then see if it's in here. So what I'll do is is number find liked in this array, and then I'll kind of by row I want to see if any one of these is true. So let's say by row lambda r, actually by row or true false. Okay. Well, that's cool, but I need to preserve this first, so let's let that be T for temporary, and then now I can filter T on by row. What are we gonna do? Is number find liked in T, and then or. Okay, so that gets you the one row that has the liked values. And we'll say text after there. So in each one, there could be more than one. There we go. It gives you the values that are being liked. Now, here in this table, let's make this a table. We're going to call this name and bring over these headers so that I can do a lookup. So for each of these headers, we're going to say is number finds in that. So we get an array of trues and falses. Let's convert these to dislikes and likes. So we'll say if this is true, then likes, otherwise dislikes. Now we need to filter this to find out which of these names matches that pattern of likes and dislikes. The way we'll do that is concat. We'll concatenate that and filter T name. So if that equals, what are we gonna do? By row, drop T, drop the first column. So concat. There we go. Those are our answers there. Nice. Okay, music Harry's. This time we have music songs here, and we have to know the name of the song. So I'm going to say equals if the left 4 of this equals song, then grab the value right beneath it. That's the name of the song. Otherwise, just maintain what we've been having. And if we copy and paste that down, there's the song names. So we'll call that songs, and we'll call this lines 2. So here, all we have to do is angst look up these lines in lines 2, return the songs, and that is the answer there. All right, level 7. This is the baddie. This is quite a hard problem, especially without lambdas. So what I'll do to start is create a new sheet, call it L7, and we have L7. Let's copy all of the data here into this new sheet. Okay. So from here, I'm going to make a data table. So let's grab this stuff right here, and I'll make a data table here, pointing at example. And then right here is where my answer is going to go, self-style input. Let's turn off the grid. Okay. From here we need to look up the inputs for each level. So whatever this value is, let's look up this column and return these columns. All right. From here, I want to know which directions we can move. So I'm just going to look up Lana over here and return that. Now I need an array of my directions. So let's take this and say mid, that, sequence, length of that, comma 1. I'm just going to copy and paste values and get rid of those. So for each direction, I want to know, can we move that way? So I'll say equals is number finds this array in this value. So trues and falses, yes we can move, or no we can't. Okay. Now, up till now, we haven't looked at the map. Here's the map. Here's the map, and we're going to copy this map because we need to make a distance map over here. So, make that. I'm going to make these columns a little smaller, and we'll call this distance. Alright, around this map, I'm going to set a guard, a distance guard of 999. That means if it hits that value, as we do iterative, iterative calculations, the guard out here sets a max of 999. So then a minimum will never be out here because it's blank or something. Okay, so we've already called this distance. Okay, so that's good. Let's go back to our original map. I'm going to call this map, and I'm going to make a copy of it here, and I'm going to populate the copy with the address. So address, we'll use a little broadcasting trick. If one as an array, then we'll return the row of map, otherwise map, and this just sets the shape. It doesn't actually do anything because 1 is always going to be true. So that sets the shape and gives the row. So if the same thing, but over here we're going to do column, map, and then 4. Okay, so that gives our addresses. Turn this into an address table, ADD. Over here, we'll make a third column, copy, and here what I want to do is replace all the water values. So choose the format from a cell, and I just want to replace everything that's blue in this area only with the letter W. And if I was smart, I would have turned off calculations before I did that. Now you can notice it's iterating through all of this. If I turned off calcs, it would have just happened instantaneously. So that's my mistake, costing me about 20 seconds maybe. Okay, but that's fine. We're done now. So that is going to be called TER for terrain. Alright, now we're back over here, and I'm going to start populating my first, no, not yet. Okay, first I want to know, where am I starting? We're starting at Q20, and we need to find the banana. So where is the banana? What address is it at? We can filter the address table that we just made by looking at where the map equals the banana. So AK9. So from Q20 to AK9, then from AK9 to the stated finished place. So those are our two things. We're ultimately going to have two copies of the map. So we have to figure from here to here and then from here to here and add the results. That's what we're doing. So if our address here, which starts at A1, equals our stated address, and that has to be anchored, then start that value at 0. Otherwise, now we're going to input our blockers, okay? So if it's not meant to be traveled on, like water, we want it to be 999. And that works for everyone except for Howard. Howard is allowed to go over water. So we're going to put a condition here to say if that is not equal to Howard, and it's water, so now we'll look at our terrain. Is it water? Over this has to be good. Okay, so if those two things are true, then put 999. We want to block it off. Otherwise, we want to find the minimum value of what's around here and add 1, and travel cost of 1 for every direction that we can travel. So what we'll do is say min, actually it's going to be, a whole set of ifs. So we're going to take the minimum of if, this is where we look at the arrows. So we want to look at each one of these. Can we travel downwards? Okay, so if that's true, then look up. It's always got to be the opposite direction here because you're from here traveling down. Okay, so otherwise 999. Alright, so we're going to do this for all 8 directions. So if that, then go left, otherwise 999. If that, then go right, 999. If that's anchor, then let's go down, 999. If that, then go bottom right, 999. Oops, comma. If that, then go bottom left, 999. If that, up left, 999. Last one. If that, then go up and right, 999. Okay, so that's the minimum value. Add 1, close out the parentheses, cross your fingers that we did something right. Okay, I almost always make some sort of mistake when I'm doing this. I'll copy my formulas. Okay, so circular references. Yes, we have to turn on our iterative calculations. I'll make maximum about 150. And if everything went well, we start here and we can go in one step the directions that this character is meant to go. So up and then the 2 diagonal downwards, which is correct. So it feels like this is right, and we have to look up our answers. So we're going to say equals filter to call dist, where to call ADD equals our ending location. So 51. So far it looks pretty good. I'm going to make a copy of this, put it over here, and we'll call this dist2. Dist2. We have to modify this slightly. So we're going to take the first part of this formula up until the min portion and replace that right there. Okay, and propagate that out. And then I think we have to also change the starting location to be this one. Oh, repropagate. Okay, now we've got dist2. So copy this down, change this to dist2, and I think those two, add them up, should be our answer. So add those two. Now we have to let the data table populate. Could take a minute. Hopefully not too long. We have some answers. Let me now turn the data table to partial calc and then see if our answers are correct. Equals that. Ta-da! Okay, so that is the tricky way to do this type of problem without any lambdas. It's only 20 minutes in. We might actually finish this. Let's see. So if you used all the apples in games 1 to 10, how many full glasses of apple cider? So this is the same formula basically, but we're going to concatenate everything first. So instead of just that, we'll say concat all your inputs. And that's right. Okay, last digits, last 10 digits of 42 factorial. So they're very similar to what we did in level 3. It's going to be reduce 1 sequence 42 lambda AV, and then we'll say mod A times 40. Oh, this time we care about V because V actually carries the value. 8 times V, and then we're going to modulate modulo 10 to the 10th. There we go. If you add up the sentence numbers that were not used in level 4, including the example, what would the total be? So level 4, we had these, right? So sequence, how many is this? 34. Sequence 34. And the sum of that is 595. So we can say equals 595 minus what's been used. Sum of this to this. Good. Alright, on level 6 tab, how many times does the word Harry and Harry's appear? Level 6. Okay, so ignoring column B, just looking at this, so we'll say equals length of this minus the length of substitute that Harry. We're going to change that to 0 characters and find the length difference. When we have that length difference, we have to divide by the length of the word Harry. Okay, so sum that up is 106, which should be our answer. If each character from level 7 starts at AZ72, goes to the banana, and then finishes at AE51, what's the total of all their moves? Okay, so for this, I'll make a copy of level 7. We're going to call it bonus 5. I should have turned off calcs or something. Okay, that works. Bonus 5. So here, instead of our game inputs, I'm going to just copy the names of the characters and then make a new data table. Oops. Alt AWT. There. So let's name this Lana. And here, instead of this XLOOKUP, we're just going to say that equals that. Here. The instructions are here. So we're going to start at AZ72. And then banana is a constant. And then the finish location is AE51. Okay. I don't think we need to change anything else. Probably. So let's just calculate this sheet and see what happens. It's not working. We get NA. See if these all seem to be pointed at. Okay, I know what it is. So level 7, no. Anything that was pointed at L7. Is there anything? These are all looking at bonus 5 as we want. So I actually don't know what's wrong here. Those are all good. What is wrong? Could it be a calculate sheet? Yeah, this should be immediate. I don't even understand formula calculation options on partial. Why wouldn't this work right away? Calculate now. Let's just do the whole thing. Instead of calculate sheet, calculate now. Just taking a minute. Come on. We got 4 minutes and 50 seconds to solve this. Let's go. Still working on data table 1. I don't know why I did this. Come on, you can do it. Let's go. Finish. Finish now. Okay. Give it a few more seconds and then I'll give up on that. Okay. So NA without any clear indication as to why. These directions look okay. I don't see any kind of messed up anchors. One thing we can do is just check. This is at BF1. Over here, we were at BF1. My OBS screen just went black, so that probably means I messed up the recording. Fuck. Let's see if I can bring this over. I don't want to lose this. I was doing well. I think maybe I'm overheating. I bet that's what I'm doing. Let me open up. Let's turn the fans on. Nitro Sense to the rescue. Still eating up time. Let's max this out. Okay, so fans are on max. I'm gonna just slide this to the back. That's okay, we're still recording. I don't have a debug idea though. It looks like we're pointing at the right area. Maybe we have a named range area issue. Maybe that's what it is. Name manager. Let's go to this sheet B5 and call this dist 3. And then let's call dist 2. Let's call that one dist 4. Okay, so now there's no naming issues. I don't know, Lambda Explorer can to the rescue maybe. No, we're getting NAs. 999, 999, 999. Okay, NA. So that's true. That's NA. Is this just a factor of the iterative calcs where it got stuck at having one error and then it propagated the rest and now it's not going to work? Maybe. I don't know the answer. But I'm desperate here. So if I take this formula and go like that, what happens? Oh, I'm getting something. I am getting something. Let's do the same thing over here. I'm getting something again. Could we finish this? That would be amazing. So where's my calculations? Calculate sheet. Okay, I don't know. Equals that plus that equals sum of that. Calculate sheet. Come on, you can do this. 909, 909, 909. Woo! Yeah! The minute to spare. That is how you solve this case with no lambdas, no macros, the old-fashioned way. Let's go. Thanks for watching. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills.
as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.